it all? Okay. Uh, in last lecture, we have covered. Hello. In last lecture, we have covered what is the conventional machining and what is the non-conventional machining. Then we see the need of non-conventional machining, right? Uh, why we require the non-conventional machining even if we are using the conventional machining from longer time. So today's lecture it will be focused on what are the similarities and differences between the conventional machining and non-conventional machining. If you are considering the conventional machining, you remind that lathe machine, drilling machine, milling machine, right? These are the certain examples of conventional machining. When you thinking about the non-conventional machining is also called as a non-traditional machining or also called as a advanced machining. If you are thinking about this non-conventional machining, you must remember that different machining processes which are based on mechanical energy, which are based on electrical energy, which are based on chemical energy, which are based on thermal energy. As we discussed all the type of the non-conventional machining based on energy in last lecture, right? We have covered the classification of non-traditional machining, non-conventional machining, or so after discussing about the need of the non-conventional machining, classification of the non-conventional machining, today in this lecture of non-conventional machining process, we mainly discuss on similarities and difference between this conventional and non-conventional. As we know that conventional machining, where we think about the lathe machine, drilling machine, grinding machine, right? How this phenomena of material removal is to be takes place, right? When you are using the drilling machine, by using the drill bit, you can drill the hole to the material and material is removed in the form of chips. Same phenomena it will be happen in case of a lathe machine, in case of the milling machine, where we require the tool to remove the material from the workpiece, and that tool are that tool may have different geometries depending upon their application. Also, they are providing good accuracy, good surface finish to the material which we have to machine. This is all about the conventional machining process. Now, what is the non-conventional machining process? When you are considering about the non-conventional machining, it is related with the absence of tool. It is related with the different forms of energy to remove the material from the workpiece. It is related with the high surface finish, high accuracy of the dimensions. So these non-conventional machining processes are having the certain advantages. Those overcome some specific limitations or disadvantages of conventional machining. That is a how to drill very small hole in a material in microns, where diameter of that hole it is in a micron. How to machine the complicated shape object. How to machine the material which is a flexible in nature like a rubber. How to mount the rubber on a machine. How to machine the rubber, right? How to remove the material from the very high hardness, from the material which is having high hardness like a titanium, right? So these are the certain limitations for the conventional machining, for which, because of which we are thinking about the non-conventional machining, non-traditional machining, or advanced machining. Now the first slide, it will indicating what are the similarities between these two machining processes, that is conventional and non-conventional. If we are considering conventional machining process and non-conventional machining, these both the processes, no doubt they are the machining processes, and they can be used to remove the material from the workpiece. Which material? The excess material, so that we can get the desired shape or desired dimension to the or desired size to the workpiece as per the drawing. So that non-conventional and conventional machining, these are the two same processes having the same purpose, that is removing the material from the workpiece, removing the excess material so that we can achieve desired size and shape to an object or workpiece. Same, both are the processes, those are having a subtractive manufacturing process. From top to bottom approach, it will be considered in both the process. Again, both are the secondary manufacturing process. Why they are secondary manufacturing process? Because we are giving the final shape and size with accuracy and surface finish to the object or to the workpiece, so that they come under the heading of secondary manufacturing process. As earlier slides or lecture, we divide the manufacturing process in two categories: primary manufacturing process and secondary manufacturing. In primary manufacturing process, we are providing basic size and shape to the workpiece, like a casting process, like a forging process, right? But in a secondary manufacturing process, we are providing the final shape to the project object. So all the material removing processes, they are come under the category of a secondary manufacturing. Both conventional as well as non-conventional manufacturing process are produce smooth and finished surface. Means they are providing very smooth surface finish to the workpiece with the close tolerance. Close tolerance, it is related with the accuracy of the machining. Although different process have different capability. If you are considering the lathe machine, it is having one standard machine capability for drilling, milling, right? All the processes are having a separate or a different capability of the machining. Even though this, both the processes can produce, both means conventional as well as non-conventional machining, they are producing very smooth object which is having a very high quality surface finish with a close tolerance of the dimension. Are you getting this similarities between conventional and non-conventional machining? Is it clear? Similarities? Hello? Please reply audibly. Is it clear? Okay. After that, just we discuss about the similarities. Now we focusing on difference. What are the different parameters, or what is the main point which will differentiating both these two processes? Now, difference between the conventional machining and non-conventional. We are dividing this into two types: conventional and non-conventional. If you are considering conventional machining process, where we use only mechanical energy, that is power, which is utilized to remove the excess material from the workpiece. Means in case of a conventional machining, conventional म्हटले की डोळ्यासमोर लेथ मशीन आली पाहिजे, ड्रिलिंग मशीन आली पाहिजे, मिलिंग मशीन आली पाहिजे, बोरिंग मशीन आली पाहिजे, थ्रेडिंग झालं पाहिजे, राईट. Where we require only power, that is mechanical energy, which will be used to remove the material from the workpiece. As compared to the conventional machining, by considering material removal as a parameter, we come across this point. Various forms of energy like electrical, mechanical, thermal, chemical, etc., and combination of any of the two are directly utilized to remove the excess material. Means, in case of a non-conventional machining process, all these non-conventional machining processes are based on a certain kind of the energy. It may be direct energy or indirect energy. Which are those? It may be a mechanical energy, it may be electrical energy, it may be a chemical energy, it may be a thermal energy, or there will be a combination of any two energies in order to remove the material, excess material directly from the workpiece. So this is the first differentiating point between conventional machining and non-conventional machining. Means it is based on form of energy which is utilized to remove the material from the workpiece. Write in short differentiating point within a minute. Okay, the next point, whatever the material, excess material you are removing from the workpiece, which is the shape of such material. That is, materials are removed in the form of tiny sharp chips. Means chips formation is to be happen in order to remove the material from the workpiece in case of the conventional machining process. That is, in case of the conventional machining process, the material is to be removed in the form of chips. If you are considering non-conventional machining, the term that chip, it will be not produced over here. Material is to be removed in various forms. It may be in the form of small metal particles, small ions, or in cases the material is to be get melt or it will be get vaporized. So there will be any form by which the material is to be removed from the workpiece in case of the non-conventional. But in case of the conventional machining, the material is to be removed only in the form of chips. This is the second point which will differentiating conventional with the non-conventional. Write this point also. Okay, next. This point it is related with the which phenomena it will occur, which phenomenon it will be occur in order to remove the material from the workpiece. If we are considering conventional machining process, shear deformation is to be happen, which will cause the removal of the material from the workpiece. That is, whatever the material which is to be removed from the workpiece in the form of chips, it is because of a shear deformation of the material. Are you getting? Whereas in non-conventional machining process, this shear deformation it will play the insignificant role in process of the material removal. Instead of a shear deformation, the material is to be removed by the process of erosion, especially in case of the um, mechanical energy based processes, dissolution, evaporation, sputtering, etc. These are the certain phenomena by which the material is to be removed in case of the non-conventional. That is, in case of a non-conventional machining, whatever the material is to be removed from the workpiece, it is because of the erosion action, chemical reaction, evaporation action, sputtering, melting. These are certain kinds of the phenomenon which will be occur because of different kind of energy like mechanical energy, electrical energy, chemical energy, and thermal energy. The role of the shear deformation, which is a more important in case of the conventional machining, but it is a very insignificant in case of a non-conventional. Okay, you take 1 minute to make a point to note down this point. Then we move with to the next point. It is related with the cutting tool. If you are considering about the non-conventional machining process, we require the cutting tool. It may be a single point or multi-point cutting tool. But that cutting tool, it must have certain specific geometry. It must be harder than the material of the workpiece, which is to be machined, and it must require certain kind of the properties, mechanical properties, which will be required for carrying out action of cutting or cutting action. That is a sharp wedge shaped cutting tool which is having specific geometry, properties and material is required for cutting action, which will be helpful to remove the material from the workpiece in the form of chips. Where in a non-conventional machining process, majority of process that does not require the cutting tool. That is, so-called cutting tool does not exist in case of the non-conventional machining process. But there are certain few processes like ECM, that is the electrochemical machining, EDM, that is the electric discharge machining. These are the certain processes where we require the tool, and the profile of this tool and properties of that tool must match with the requirement. What care it should be taken over here? Whatever the tool you are choosing, its profile and its material or material properties, they must be matched with the requirement of the material removal. That is, in case of a non-conventional machining process, majority of the process they does not require the tool to remove the material from the workpiece. But there are certain processes where we are providing a profile shape tool. Which type of the shape you have to generate on a workpiece? The same profile of the tool it will be produced, so that that shape can be produced on the workpiece. So that profile can be generated on a workpiece. This is the difference between these two processes by considering cutting tool. You write the difference and make its point. Is it over? Okay. The next differentiating point it is related with the contact between tool and the workpiece. In case of a conventional machining like lathe, drilling, milling machine, there will be a physical contact between the cutting tool and the workpiece. Also, there will be a relative motion between them, and it is very necessary to to remove the material from the workpiece. In certain cases, if you are considering the drilling machine, where tool is rotating, workpiece is stationary. But there will be a relative motion between tool and the workpiece. Drill bit rotate होत असतं, वर्कपीस आपण माउंट केलेलं असतं चेक मध्ये, राईट, जॉब मध्ये, वाईस मध्ये. If you are considering the turning process or different operations performed on a lathe, where the workpiece which we are loading or mounting in a chair, it will be rotating, right? And we are moving the tool against that workpiece. It may be linearly as well as laterally. So there will be a certain movement between the tool and the workpiece, and that movement is essential. It is necessary in order to remove the material from the workpiece. It is all about the conventional machining process, that is which is related with the physical content that will be required to remove the material from the workpiece. Then, if you think about the non-conventional machining process, there will be no physical contact occurs between the cutting tool and the workpiece, because where we not require the tool, that tool concept is not valid in case of the non-conventional machining. But there are certain processes, few processes like abrasive jet machining, water jet machining, ultrasonic machining, where solid abrasive grids, they are strike to the work surface, and they are removing the material from the surface of the workpiece by the action of the erosion. By the action of the erosion means there will be no direct physical contact of the workpiece and material of the, there will be no direct contact between tool and the workpiece. This slide, it will be focused on, in case of conventional machining, there will be a physical contact between tool and the workpiece. At the same time, there must be a relative motion between the tool and workpiece in order to remove the material from the workpiece in case of the conventional machining. But in case of the non-conventional machining, the concept of the tool, it will be absent. There will be no need to have a tool, but in certain cases it may require. If you are considering the ultrasonic machining, where we require the tool, but there will be no direct contact of that tool with the workpiece. We are using certain kinds of the abrasive particles, small tiny sharp edge particles. They are removing the material from the surface of the workpiece by the action of the erosion. So you read this slide and you mark some points, differentiating points. Okay, come to the next point. If you are considering the conventional machining processes, these are the age old, and thus physics of such processes is a very well understood and well known to all of us. If you are considering the various operations performed on a lathe machine, how to carry it out turning operation, how to carry it out facing operation, how will the movement of the tool, how will you mount the workpiece on the machine by using the tailstock, spindle, chuck. These are well-known terms for all of us, and we know the material is to be removed because of action of a shear force, shear deformation, and that shear deformation it will occur as we are pressing the tool against the rotating workpiece. Means that concept it is a well known, or we can well understood that process. So skilled labors are also readily available and comparatively with the low cost. As we know that there are many operators, those are working on a conventional lathe, right? And these are the some semi-skill or skill operators, and they are easily available with the minimum payment range or minimum wages, right? In case of a conventional machining, if you are considering the CNC machining, then CNC programmer and CNC operator, these are the two different positions, right? If any person which is working on a traditional lathe machine, he is unable to work on a CNC machine. He only start the machine and end the machine. But programming is the main issue where we require the technical expertise, right? So whatever the operators, those are using the conventional machines, they are having limited skill and they are easily available on less cost or less wage, pagar, on less amount of a salary. But if you are considering the non-conventional machining process, most of the processes are in developing stage now. So we require the operator or labor which is having a very high skill, but such operators are not easily available. So we have to provide more labor cost in case of a non-conventional machining process, because non-conventional machining process they are utilizing different forms of energy to remove the material from the workpiece. If we are considering the uh, plasma arc machining, just we today only know what is this plasma arc machining process, right? How it operates, which kind of care it should be taken, right? Which kind of the instruments we require to control the process, right? Which are the major parameters you have to make constant while conducting the different operations by using the plasma arc machining. That complete idea no one should have. For that purpose, we first require the training, how to handle or how to operate such machines. It is required. Then, after getting that training, that personnel will become an expert in that particular machining operation only, right? He does not aware about the water jet machining. He does not aware about the ultrasonic machining, right? So most of the processes they come under the developing stage. We require the number of skilled labor because as the processes are in developing stage, no one will have mastery in that field of operation. So such kind of a labor, when you hire, it will require major payments or ultimately the cost of labor, it will be high in case of non-conventional machining, right? So this slide, it will be related with the uh, concept, skill of labor, and cost of the labor. Read it carefully and mark the point. Write down this point. Okay. Now this slide, which will differentiating conventional and non-conventional machining, which is based on the surface finish which will obtain, and at the same time uh, how this surface finish is to be obtained, and which parameter you have to control to obtain better level of surface finish. In case of a conventional machining process, it will help to provide a wide range of surface finish depending on the process that is employed, and what are the parameters those are control in order to improve the surface finish of the workpiece. However, the surface finish which is below 10 micrometers is quite difficult to obtain such a high quality surface finish. We require CNC machining, which is a certain costlier one as compared to the conventional machining. Means there will be certain limitations for the conventional machining process to provide the high quality surface finish below the 10 micrometers. It is quite difficult for such. We are getting the surface finish with a wide range by controlling the different parameters in case of the conventional machining. Whereas in non-conventional machining, the achievable surface finish is much better than that of the conventional process. Whatever the surface finish you are obtained by using the non-conventional machining, no doubt it is a very better in quality better better than the conventional machining process. It can easily provide surface finish in nanometer range, right? Means in case of a non-conventional machining process, we can able to provide a surface finish which will be measured in terms of nanometers. Here, how much quality of surface finish is to be obtained by using the non-conventional machining. That is the main difference. In case of a conventional machining, wide range of surface finish can be obtained, but to obtain better surface finish, at least you require costly CNC machines. But in case of a non-conventional machining, definitely you can provide the surface finish which is better than conventional machining process. But at the same time, the quality of that surface finish it can be achieved in a range of nanometers. In a range of nanometers. Here, read this point and write the difference. Okay, next point. Come to the next point. Whatever the material is to be removed from the workpiece in case of a conventional machining process, it will be in the form of chips, no doubt, but it will be in a large quantity. That is the bulk removal of materials to be happen. And even they are removing the material in the bulk form. These processes are also fast because they does not produce the more surface finish. They are providing a certain range of the surface finish by using by machining operation. As they are removing the material in the bulk form, These processes are fast, reliable, economic, as the material remove rate in case of the non-conventional machining process as compared to the in case of a conventional machining process while comparing with the non-conventional machining process, the material remove rate it will be a high. Are you understood? Whatever the material is to be removed in case of a conventional machining. Conventional machining, when you are dealing with this term, this word, you just imagine lathe machine. Whatever the material is to be removed, it is in a bulk quantity, and the material remove rate it will be higher in case of a conventional machining process. But in case of a non-conventional machining process, excuse, hello, hello. In case of a non-conventional machining process, hello, sorry, there will be some urgent call from higher authority. In case of a conventional machining process, material remove rate, that is MRR, it is a very high as compared to this non-conventional machining process. But the non-conventional machining process, they are suitable for highly accurate and precise requirement. There will be a bulk removal of material if required. It will consume more time to remove the material, and these materials are less reliable and uneconomic when we are thinking about a removal of the material in a bulk amount, right? So this is the main comparative point between conventional machining and non-conventional machining. It is related with the material remove rate. The material remove rate it is higher in conventional machining and lower in non-conventional machining. But when we go for the more material removal, that process it will be become a less reliable, uneconomic, and time consuming. Read this slide and Okay. The next comparative point between these two processes, in case of a conventional machining process, there are certain shapes that cannot be produced by conventional machining process. Hello. Lecture मध्ये जरा एक पडलं. हा. Means by using the conventional machining process, certain complicated shapes, right, critical shapes cannot be easily manufactured. But in case of a non-conventional machining process, we are easily produce certain critical shapes. Those are not feasible by using the conventional machining process. Means critical shape objects, small diameter holes. The whole diameter it is in microns. It will be not possible by using drilling machine, conventional drilling machine. So this is the slide which will differentiating uh, the point which will related with the shape, complicated shape, which will be feasible by conventional or non-conventional machine. Read this point and write it. The next point regarding the machining of the certain materials, those are having a flexibility like rubber. While machining the material which is having a flexibility, it will be quite difficult in case of a conventional machining because mounting of a such flexible material on a machine, it is also one of the challenging work. Then another challenge is how to machine such flexible material. But in case of a non-traditional or non-conventional machining process, such kind of the flexible material like rubber can be easily machined, can be easily worked. So this is the main point. Another point, I think that will be not covered in slide regarding the hardness, flexible that as well as the material which is having a very high hardness, they cannot be machined by using the conventional machining process like lathe drilling, boring, or milling. But such materials can be easily machined by using the non-conventional machining like uh, abrasive jet machining, ultrasonic machining, right? Like that. So this is the another point, differentiating point between conventional and non-conventional. So read it. This slide gives the example of conventional machining processes like turning, facing, growing, drilling, shaping, planning, milling, grinding, honing. And this slide it will give the examples of non-traditional machining like abrasive jet machining, abrasive water jet machining, ultrasonic machining, etc. Or hybridization of above process. Write the examples of conventional machining process and non-conventional machining. Is it over? These are the references those you require to finalize the differentiating point between conventional machining and non-conventional. Are you getting this? Okay, just we will take a recap. We deal about the what is the conventional machining, what is the non-conventional machining, what are the points which will show the similarities between the conventional and non-conventional machining. Then we start with the differentiating point. This is the first point, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11. Means near about 11 to 12. One more point related with hardness. We can differentiate on hardness of the material. Conventional machining process are not able to machine the material which is having a very high hardness, like a titanium, right? Such a material can be easily machined by using the non-conventional. So this between conventional and non-conventional machining, that point we are easily cover over here. If anybody have any doubt, please ask me. Right now, I request all the students to mark your attendance in chat box. Everyone have to mark his attendance in chat box. His or her attendance. Sorry. Okay, is it over? Everyone have marked attendance.